All right. Last time we started talking about voting systems. So these are ways of taking people's preferences and deciding which candidate or which option is the most preferable. And one of the first things that we said was that if we have only two options, then our normal defaults, whoever gets the most votes wins, ideas work pretty well. Like majority wins is a very democratic idea. The issue comes in when we have more than two options. We can have some conflicting goals that lead to things like paradoxes or results that don't quite agree with the way that we think that a voting system should work. And as we'll see right at the end of this video, there really is no right answer. We're always going to have to make some trade-offs with what types of properties, what types of voting systems we actually want to implement. It's tempting to look at this statement and say, oh, well, a lot of decisions that we make are just between two options. That shouldn't really be a problem. Well, usually when we're faced with two options, there has already been some narrowing down of what those options are. So if we're talking about things like elections, you have two parties that go through their complicated primary process to pick out their one candidate, and then that eventually these candidates, have the election going head to head. And there are often a lot of other systems that can rephrase what's actually a choice between many different options into just a binary choice between two. So today we're talking about a few paradoxes or situations that lead to outcomes that maybe aren't quite the fairest. Our first of these is this historical example. So in 1956, the US House of Representatives put forward this school construction bill. The idea was that they were going to provide new funds for the states to build more schools. And in this long bill writing process, an amendment was proposed that would prohibit these funds to be used in segregated schools. Remember, this is 1956. So when this amendment was brought up, there really became three options. The bill could pass in its original form, the bill could pass in its amended form with this condition about the funds being used in segregated schools, or the bill could just not pass. So we're going to designate those O, A, and N. And at the time, there were really three main voting blocks in this US House of Representatives. The Democrats certainly had a majority, but they were somewhat split between Northern Democrats and Southern Democrats. So the Southern Democrats liked this bill. They wanted to allocate more funds to build more schools. However, they really did not like this amendment. So their order of preferences between the three options was that they wanted the original, and if they didn't get the original, they didn't want anything to happen. They didn't want to be spending money on these other states that wouldn't have segregated schools. And then lastly, their third choice would be the amended version. The Northern Democrats liked the amendment, and if they couldn't get the amended version, then the original would be fine. And then lastly, they would want it to not pass. Republicans did not want this bill to pass, but if it did pass, they'd prefer it to be the amended version, likely because there would just be less money spent. And then lastly, the original version. So we have the orders of preferences for each of these groups, and certainly these groups weren't actually equal sized, but for all intents and purposes, we can think of them as being roughly a third of the voting block. And we can look at these preference orders and realize that there's sort of no obvious answer as to what the best result should be, what results. So if we look at these preference orders, we can realize that there really is no best answer. So here's what actually happened. So the way the system works, the way the US House of Representatives decides on what gets added to a bill, is that first the entire House votes on whether or not the amendment is added or not. So the first vote is, do we stick with the original or do we add the amendment? And then once that's been decided, there's an up or down vote. Do we accept the bill or not? So if we voted to keep it as the original, then we would decide, all right, original or not passed. And if instead we voted for the amended version, we decide amended or not passed. So because of this, we can figure out what happened based off of everyone's preferences. So the first question is between the original versus the amendment. So we're only paying attention to O versus A. So O beats A in one of these blocks. However, A beats O in two of them. So as you can imagine, the amendment was added to the bill. So we ended up going in this direction. Now that we're here, the question is between A and N. And if we look, we can see that, well, N wins in 2 out of 3 of the options. Therefore, the bill was not passed. So this sort of tiered system is a perfectly valid voting system. It was a way of taking individuals' preferences and returning a result. It ended up being that the bill was not passed. We resulted in N winning. Um, However, this is not one of the systems we talked about, largely because it's, in a sense, favoring one result over another, at least in this context. So given people's preferences, it certainly wasn't clear who should win or which option should win. However, it was the ordering in which we cast or in which we had these head-to-head competitions that ended up dictating which option won out at the end. So this is an example of taking a complicated 3-option question and, in a sense, clumsily narrowing it down to just multiple 2-option questions. So 2-option questions are great when they're actually 2-option questions, but when we're using that as a method for narrowing things down, we can end up inadvertently favoring one option or the other. So last time we talked about some good properties that we would look for in voting systems. And one of the suggestions was this idea of unanimity, that let's say that every single voter likes A more than B. It would be weird if our end result, if our voting system came up with an answer that had B over A. So unanimity is the property that if everyone prefers A to B, then the voting system returns A beating B. So that's a good property to have. So here are a few others. One is that we don't like this spoiler effect. If we have a close race between 2 parties, we don't want it to be the case that if a third party comes in, then they're going to draw votes away from an ally, a sort of a similar party. Yeah. So this is often discussed in US politics. This happens all the time when you have third party challengers. They typically more align with one of the candidates and disproportionately draw voters away from that one, which, if they align with that candidate, is probably not something that they want to be doing. So ideally, we would have a voting system that doesn't penalize voters for voting for a candidate or an option that they most want, rather than incentivizing strategic voting like we typically have. Another property is that it would be great if all votes were counted the same, or that there was some symmetry, that if we just switched who was casting which vote, we would end up with the same result. So a sort of weaker version of the statement is just that, at the very least, we don't want this to be a dictatorship. So a dictatorship is a voting system where one person casts their vote and everyone else can also cast their votes, but the voting system is only listening to that dictator. The voting system always returns the exact ordering of that single designated person. So it seems like a good property of a voting system to say that we don't want that. We want non-dictatorships. Yeah. And there are many, many other properties that make for good voting systems. The last one that I want to discuss here is called the independence of irrelevant alternatives. So imagine that you're hanging out with a friend and your friend offers you ice cream and says, hey, I have vanilla ice cream and I have chocolate ice cream. Which do you want? And you say, great, cool. Vanilla, I like vanilla ice cream. And then the friend goes back and searches around and says, oh, by the way, I also have strawberry ice cream. And then your response is, oh, well, in that case, I'll take the chocolate. Well, that doesn't make any sense, right? Why would the existence of the strawberry ice cream change your preference order between vanilla and chocolate? So in this case, strawberry is an irrelevant alternative. If what we're focusing on is, do you prefer chocolate or vanilla, the existence of this third option shouldn't change the fact that you wanted vanilla more than chocolate. All right. So more formally, if we have some voting system that ranks A over B, and some voter changes their view on a third option, let's call it C, that shouldn't change the system's answer about A versus B. And this seems like the type of thing that, like, yeah, of course we want this property to happen. It would be really weird if changing something irrelevant is going to affect sort of our main question of, like, hey, is A better than B or not? So unfortunately, many of these are contradictory. So there's this famous theorem called Arrow's impossibility theorem, which says that if a voting system has unanimity, which, as we said, is sort of a pretty obvious property to have, as well as this independence of irrelevant alternatives, meaning the existence of that strawberry ice cream shouldn't change our preference of vanilla over chocolate, then the only possible way that this works, the only way to have unanimity and independence of irrelevant alternatives, is for it to actually be a dictatorship. So in other words, it's impossible to have these three properties at the same time. So this is basically saying there is no right answer. There are systems that do better at various properties, do better at accomplishing various goals, but we can't have something perfect. This no spoiler effect is actually especially tricky, and also a difficult one to pin down. The proof of Arrow's impossibility theorem is certainly something that we can do. There's a little bit of trickiness with comparing testing ballots versus other ballots. But if we had one more day in the semester, we would spend class time going over this. I'll provide a video proof of this, and it's optional, but I certainly encourage you to at least take a look at it because it uses some techniques that we've been talking about. That said, in this case, I don't think it's worth dedicating actual class time towards. I want to go through the details of at least one of these paradoxical situations here. So say we are trying to determine what the best breakfast food is. So we're comparing bagels, cereals, and danishes. So we're going to determine this by taking a vote. We're going to take a class of, let's see, 17 people, and we're going to ask them not just what is your favorite breakfast, but what's your actual preference order? What's your favorite? What's your second favorite? Third favorite? We're doing a ranked choice voting. And let's say that we do one of the runoff approaches. So when there's only three options, the instant runoff and the two-stage runoff are actually the same thing. Once you do the runoff, you're doing a runoff, and that's it. So let's figure out who wins or what the voting system. So let's figure out what this voting system. So let's figure out what this runoff voting system has to say about this collection of preferences. Notice that Danish, gets a total of 6 first place votes. Cereal gets 6 first place votes. Bagel only gets 5 first place votes. So according to our runoff procedure, we remove bagel from the picture, and now we ask between cereal and Danish, what's the preference? Well, in this case, cereal beats Danish. Okay, so to determine who's second, we need to put bagel back in. And now, since we already know that cereal won, now we'll remove cereal from the picture and ask ourselves, all right, bagel or Danish? Well, in this case, Danish wins. So our final ordering is cereal, Danish, bagel. Okay, so that's all well and good, but let's say that these two people who originally voted Danish, cereal, bagel have changed their minds. Maybe they had a bad Danish or they had some really good cereal, and now they're voting cereal above Danish. So here's the identical ordering I just copied and pasted, but now we're going to switch. These two people now like cereal more than Danish. So in this case, the only change is that more people like cereal more, but let's see what effect this has on this voting system. What does our runoff system say about this collection? Well, now cereal gets the most votes. Bagel gets 5 votes. Danish now only has 4. So our runoff procedure says that we're removing Danish. And now we ask ourselves, all right, in this runoff, who wins? Well, bagel gets 9 votes to cereal's 8 votes. Therefore, the first choice is bagel. We can go through this process to see who wins between cereal and Danish, but I believe that cereal ends up beating Danish. So we have a new winner. In this case, bagel is the top choice. So all that's changed is that between our first round and our second round, more people like cereal. Cereal won in the first round, but has somehow lost ground because more people like it, that doesn't seem right. So many ranked choice voting systems, like runoff elections, have a lot of things going for them. They make the existence of third party candidates or third options a actual feasible choice in what was previously a two-party system. And there are a lot of other benefits. However, in any of these voting systems, thanks to Arrow's theorem, there is always going to be something at least slightly off about it. We're always going to be able to find some paradox somewhere, like this one, that illustrates that, hey, some weird system is going to happen. And that's just the way it works, which makes Arrow's theorem sort of one of my favorites because it's just proving that there is no perfect system. I don't want to go out on a negative vote like that. So I definitely want to also point out that Arrow's theorem only applies to ranked choice voting systems, where the information that we have is just the ordering of people's preferences. There are other systems like approval voting or systems where you have a certain number of points that you allocate really however you want amongst your options. And these systems don't fall under the purview of Arrow's impossibility theorem. It's possible to have unanimity and independence of relevant alternatives. However, there are often other issues with those. But while there are problems in some edge cases like this paradox, for the most part, systems like instant runoff systems are often better approaches than, let's say, our current election system, which deals with primaries, which is a very, I believe I called it, clumsy way of narrowing the field down to just two choices. There are many problems with that. It encourages strict two-party systems. People end up having to vote for the lesser of two evils more often than not. Um, and I am personally a big fan of systems like instant runoffs, despite some weird mathematical edge cases like this paradox.